minor and cofactor. So let your metric to be square metric. You can see n times n is square metric. For 3 by 3, 4 by 4, 5 by 5 order of matrices. So the minor Mij of the element is the determinant of the matrix obtained by eliminating or deleting the I row and j column. What's the meaning of that? So let's say this is my matrix a square matrix A here, 3 by 3. Let's say I say M12. It will be going to eliminating, or I call it deleting the I row j column. So first row and second column. Determinant of that matrix, determinant of 3, 2, 1, 3. So this is how you're doing minor. Deleting the row, the remaining element here, we're doing the determinant. So determinant 2 by 2 will be obtained by AD minus BC. So this is the meaning of minor. Meanwhile, for cofactor, it will be positive or negative. I can define here either positive or negative for our minor. According to the position, I row and j column. So we simplify like that. So first row, first column positive. Because first row is 1, first column is 1, so 1 plus 1, this negative 1 will be power of 2, so it will be positive. Alright, so first row, second column, it will be negative because 1 plus 2, power of 3, it will be negative 1. First row, third column, positive. For first row, third column, negative 1 will be going to power 4, so it will be positive. And so on. So negative, positive, negative, positive, negative, positive. Simple to be said, cofactor is like add on the positive, negative for that minor. So if I want to find cofactor 1, 2, 1, 2 will be in the position here. It will be minor of negative of minor 1, 2. So negative of 7. Okay, so cofactor and minor. Minor, deleting I row and j column. Cofactor, just add on the properties positive or negative for the corresponding position here. Okay, so let's say we can repeat. You see, when you say M11, M11 will be eliminating first row, first column. So that's why we're doing the determinant for 4, 4, 2, 3. So AD minus BC, we get 4. When we come to cofactor 1, 1, so you see cofactor 1, 1, it will be in the positive position. Positive for M11, so it will be equal to negative 4. So it will be easy like this. This one no need. So you just remember the positive and negative just alternating one each other. Positive, also negative, negative, positive, alternating. Start with positive first. Alright, so you can see example for minor 3, 2, minor 3, 2, eliminating row 3, column 2. So determinant of this remaining element 1, 3, negative 2. So AD minus BC, 2 minus negative 3, we get 5. For position, cofactor, we finding the position 3, 2, 3, 2, 3, 2 in the position of negative. So that's why for cofactor 3, 2, it will be negative minus 3, 2. So negative 5. Answer will be negative 5. Alright, so minor eliminating row, do the AD minus BC. Cofactor, just put in your positive or negative for your minor. So you call it cofactor. So let's say we see this example. Matrix A, we need to find minor 1, 2, cofactor 1, 2. So for minor 1, 2, we will eliminate for first row, second column. So we are doing the determinant for -2, 4, 4, -3. AD minus BC, it gives us -10. So when we want to move on to cofactor, we remind again cofactor position, positive, negative, positive, negative, positive, negative, positive, negative, positive. So for cofactor 1, 2 position is at negative. So cofactor 1, 2 will be negative of the minor, negative of -10. So we get 10. Continue for section B. Minor for 3, 1. So 3, row first. Okay, the order here we will rename with row first followed by column. So third row, first column. Macam aras 3, bilik 1, cancel. So yang tinggal sini kena buat determinant -4, -2, kosong 4. Okay, buat AD minus BC, -16 minus 0, so -16. Meanwhile for cofactor, we put in positive or negative for that position. So 3, 1, position is at positive. It will equal to positive minus 3, 1. So from here we can see, if we want to get cofactor, we must have minor first. Alright? We can't straight away we get minor, because cofactor is depending to our minor, whether in the position positive or negative only.